Alright, CNT125, Chapter 12, Layer 1 WAN Technologies, Sonet, Synchronous Optical Network. Synchronous Optical Network, or Sonet, high bandwidth WAN signaling technique, developed in the 80s by Bell Communications Research, and eventually standardized by ANSI and ITU. What we're going to find out is this is a technology often used between ISPs to connect sites. So high bandwidth connection between them, really ideal. This is going to specify framing and multiplexing techniques at layer 1. Four of the key strengths that they mention about Sonet are can integrate many other WAN technologies, hence something that ISPs might use. Offers fast data transfer rates. Again, hence why ISPs might connect their Chicago to New York to Philly sites together. Allows for simple link additions, removals. Yeah, so I can easily add a node or remove a node, add a site or remove a site from it. Provides a high degree of fault tolerance. Yes, the dual fiber ring structure here, I have a high fault tolerance on my system. So synchronous in terms of Sonet actually means that the data being transmitted and received must conform to a timing scheme. There's a clock that maintains time for all the nodes on a network. We're actually going to come back to this in just a minute in like another slide here where we talk about that in a little bit more detail. So kind of hold that on, put that on the shelf for right now. One of the most important Sonet advantages is interoperability. It can connect different technologies together. It can aggregate multiple T1s or T3s. It is an underlying technology for ATM. Okay, so there's a lot of it can do it technology going on with Sonet. Can work directly with different standards used in different countries. So again, interoperability between continents. This becomes a really good choice for linking WANs between North America, Europe, Asia, etc. The international implementation of Sonet is actually called SDH, Synchronous Digital Hierarchy. Okay, so stick that one in the back of your brain along with Sonet. SDH and Sonet kind of go together. Sonet is not primarily used as the last mile service, pretty much a WAN link between. Sonet more often traverses multiple ISP networks, connecting these, making like, internet backbone kind of deal. Sonet functions on fiber optic cabling. It must interact with other types of media, but it's mostly functions on fiber optic cabling, as we'll see in some of the pictures later on. Sonet multiplexers accept input from different network types, T1 line, etc., and formats the data in a standard Sonet frame. So bringing it in and putting it in the Sonet frame to move it across the network. The multiplexers combine individual Sonet signals on transmit end, and a demultiplexer on the receive end separates the combined signals back out. So your Sonet multiplexers are going to combine those together, move it across the network, gets the other end, demultiplex them back out to the original signals, if you will. Here we go. Coming back to the timing that we mentioned a little bit ago, Sonet's transmissions rely on carefully orchestrated timing. The Sonet frames are set on a regular schedule, whether or not they contain data. So they use the example in the book of like a city bus system. And that's actually a really good example. So think about a city bus that's driving around doing a loop of, to the Capitol, to this building, to this parking lot, back to the Capitol, doing a loop around the city all day long. Well, when it gets to a stop, it'll open the doors. If there's people to get on, great. If not, it'll close the doors, pull out, and go to the next stop. That's exactly how Sonet works. These frames are going to set out on a regular schedule, whether it has data or not, and keeps it moving through the network. And the frames will travel without data rather than disrupt the schedule of moving data through the network. So it's kind of impossible to keep all Sonet devices sync perfectly, but the Sonet frames that are consistent size and include information where the payload begins kind of makes up for that. That overhead information is not collected at the beginning of a transmission. Info is interleaved in among the data bits. So I don't actually have a should say a header field, if you will, that is actually interleaved in here. Here it is here. Here's payload, little piece, so forth. That overhead information interleaved with the frame's payload. The pattern is repeated 9 times per frame. So the header is, there isn't just one big long giant header, little bit scattered through the Sonet frame. The data rates of Sonet connections are indicated by its OC level, optical carrier level. That rating is internationally recognized, and your OC levels in Sonet are very similar to the digital signal levels when you were talking T1s. This is actually a chart from the older version of the book, but it's the same data. This just shows up better. Here's your OC levels over here, OC1, OC12, so forth, and showing the data rates for them. Well, you notice the OC1 is 51 meg. OC3, we're up to 155 meg. It gives you an idea that this is really a kind of like a carrier grade technology, ISP grade technology to connect sites together, just to kind of put it in a framework for you. Sonet is not typically implemented by small or medium businesses, too high of a cost, commonly used by large companies or long-distance companies, long-distance phone companies kind of thing, ISPs, telephone companies to connect your COs. That's where you're typically going to find this. Sonet is suited for audio, video, and imaging data transmission, so it can handle it all. And given its reliance on fiber optic and its redundancy requirements, Sonet technology is expensive to deal with, but you're getting the benefits of that reliability and so forth. The Sonet ring itself begins at the telecom carrier facility, and it's going to connect organizations, multiple WAN sites in kind of a ring fashion. So if I take a peek here, this is a picture from an earlier version of the book. Here would be a Sonet multiplexer, and I have, different sites connected in, whether it be a telephone switch, router, DSL modem, etc. kind of thing. And what you see is you have incoming ring 1, outgoing ring 1, incoming ring 2, outgoing ring 2. So it looks very much like a star, but as I start connecting these up with other sites, here's what you start running into. This would be your T1 multiplexer, Sonet multiplexer, Sonet multiplexer, Sonet multiplexer, Sonet multiplexer, basically making a ring between these sites. These might be, Harrisburg, Pittsburgh, Philly, etc. kind of thing. And then these would be the people subscribing to. Okay. Now we start looking so forth like this. This, like a MAN, if you will. Service provider, I'm connecting into it. It's giving me a ring between my sites. And now I have a redundant, high redundancy ring between my sites, maybe downtown or between buildings downtown. This is the time I like to pick on Harrisburg. Harrisburg being the state capital, there's a lot of state buildings in Harrisburg. These could all be connected together with a Sonet ring, a Sonet ring for high availability, high redundancy. And why they're high redundancy is if you have a break in lines here, these are designed to basically wrap the signaling. So if I have a backhoe cuts lines here, this can loop the signaling back and run it this way, run it back this way, and keep connectivity at all 4 sites even though this is broken. Yeah, you have some bandwidth loss, but I still have connectivity. That's where the high availability, high redundancy comes in with Sonet. Alrighty, we'll come back to the next one and start talking layer 2.